Here we have an example kinematics problem involving a shot put. Here it's being thrown up in the air with a certain velocity, and we're trying to find out what maximum height this ball will rise to. How high will it go up in the air? Now, we always try to list the given that the problem gives us and write them in a nice fashion. Here we realize that the ball is initially thrown up in the air with a certain velocity of 19.1 meters per second. We also know that when a ball is thrown from the ground straight up, the velocity initial at the bottom can be whatever, but the final velocity at the top will always be the same. At its maximum height, for an instant, the ball will reach a speed of 0 meters per second. Before it turns around and starts falling back down towards the earth, it will always stop for an instant. So we can use this bit of information. The final velocity is 0. Now, we need one more bit of information. Any kinematics problem we want to solve, you always have to know three things. And the last thing we know is that this ball is floating in the air, not with just any forces acting on it, but a very specific force, G. And the force of gravity is acting downwards, which is in the opposite direction which the ball is thrown. The ball is thrown up, we'll call that a positive direction. The ball is being pulled downwards due to gravity in the negative direction. So we're going to say there is a negative g acting on this. This is an acceleration. Gravity is always an acceleration. And it's negative g. And this g on the surface of the Earth is always the same at 9.81 meters per second squared. There. And lastly, what is the maximum height? This is the displacement. This is what the problem's asking us to find. We're anticipating that this answer should come out positive since the ball traveled in a positive direction, with the initial being lower than the final. Now, the equation we use for this should be one that includes all four of these variables here: VI, VF, A, and X. We could search our four kinematic equations for them, but I have it right here, already chosen. VF, VI, A, and X. Let's see how well it fits right there. That's good. Alright, next we need to take this equation here and solve it for the variable here. So let's cut this out one more time, copy it, paste it, start over here. Taking this equation and solve it for delta x, we want to solve for this variable right here, which means we first need to get this term by itself. A term being anything that's being multiplied or divided by a given variable. To get this by itself, we first have to get rid of the vi squared, so I will subtract it from both sides. Vi squared minus vi squared. Vi squared minus vi squared is 0, that goes away. On the left, we have vf squared minus vi squared equals everything on the right, 2a delta x. Still want to get this delta x by itself. To get rid of the 2 and the a, since they're being multiplied, we divide them away. Whatever we do to one side, we have to do to the other. Alright, the 2's cancel, the a's cancel. What I'm left with is the delta x equals vf squared minus vi squared over 2a. With our equation solved for delta x, we can now take our given, plug them into the equation. We have VF. VF is 0. 0 squared. Minus VI squared. VI was 19.1 meters per second. And this whole thing here needs to be squared. All of this divided by 2, as well as our acceleration, negative 9.81 meters per second squared. Alright, whoop. There we go. Alright, scrolling down over here. This we are now ready to put in our calculator. Okay. 19.1 squared, 19.1 square root, I don't think so, times 19.1 divided by 2 divided by 9.81 is 18.59. Alright. 18.59, our units will be meters. On top we have meters squared per second squared. On bottom we only have meters per second squared. Meters squared per second squared. On bottom we have meters per second squared. The second squared cancel out. One of the meters on bottom cancels one of them on top. And as you can see, we're only left with the meters. That's how we determine the unit. So let me bring that back over here, 18.59 meters. 18.59 meters. And since we're mainly doing multiplication here, all of our units have 1, 2, 3, 1, 2, 3 significant figures, so we should round this one, our answer, to 3 sig figs, 18.6 meters. And that is our answer.